Okay, let's start 2 minutes past 2 p.m. So, good afternoon to everyone and welcome to the next Alaska Tech Talk with number 5 today. I am Matej Feder from the Nation Company, which is founding member of Alaska Association, and I have the pleasure today to moderate this great Tech Talk. As usual, the meeting is being recorded right now. The record will be available on YouTube a few days after this talk, so everyone can see that afterwards. Just search for Alaska Tech Talk on YouTube. Mm, agenda. Let's start with today's agenda. First, we will go through the short introduction to Alaska Tech-Talks for everyone who joined us today for the first time. Then we will have today's Tech Talk, which will be presented by Jacek Galowicz. This is the main point of the agenda. And in the end, I will share some interesting events and news with you, and it will be great if also you can share some interesting news and events from your community with us. And also the topic of the next Tech Talk that will take place at the end of June will be announced as well. So short introduction to Alaska Tech Talks for newcomers. Let's say Alaska Tech Talk is a place or a platform to discuss cloud technologies that improve clouds in many fields like openness, sovereignty, energy efficiency, performance, and more. The focus of this talk is cloud oriented but wide, let's say. So do not hesitate to propose any topic for the next Tech Talk. This platform is here to be fully open to everyone. It means that everyone can join this Tech Talk as an audience member, and if anyone wants to share some interesting topic with us, it is also possible and open and more than welcome. I will provide some details about how to be a speaker at the end of today's talk, today's meeting. This Tech Talk was initially hosted by Cloud and Heat technology company under the code name GC Tech Talk, and from January 23 is hosted by the Alaska Association. Stay tuned and visit the Alaska website, download the calendar, or subscribe to the Alaska newsletter by emailing hello@alaska.cloud. Past Tech Talks have been recorded as well, and all are available on the Alaska YouTube channel. And that's it regarding the short intro to Alaska Tech Talks. Let's proceed and move to the main part, which is today's Tech Talk. And it's my pleasure to introduce you to speaker Jacek Galowicz. He is a consultant and author at nixcademy.com. He is going to present to us the Nix package manager and NixOS in cloud. We will discover what is NixOS, where it comes from, and whether it will disrupt our current Kubernetes setup if we will decide to use this technology. Jacek will also uncover what the future could look like with NixOS. So, Jacek, the stage is yours, and take over the share screening.
Okay, let me try to share. A moment. Okay. Now, can you see my the first slide?
Not yet.
Not yet. I see just a black screen.
Okay, it says you're screen sharing. I have a little preview picture that looks correct for me at least. But it's still black, yes?
Yes, still black, at least on my side. Ah, now it's working right now. Okay.
Oh, so the full screen doesn't. Let me share my whole screen then 1 moment.
Mm-hmm.
Seems like it didn't like the full screen at the top. Okay, now.
Working.
Very good. Okay, I won't see anything else apart from my slides now. So if you feel the need to interrupt me, please do so acoustically. Thanks, Matej, for the nice introduction. So today I will talk about Nix and NixOS and Cloud IT. Let's dive right in. This will be quite a stretch in the 20 minutes time frame, but I hope to give you an image of the most important and most interesting things. So present is that we have like many companies who provide Kubernetes clusters to their customers. And of course, they use so many different technologies in their stack. There could be like twice as many technology logos here. And that might have been working like great for the last years. And then suddenly some wild new technology like NixOS appears. And it seems to be already too big to ignore. And people have questions like, what does this mean for cloud IT? Will it be kind of disruptive to any other technology that we use already? Will it substitute stuff? We will need to relearn everything, or will we actually be able to combine it nicely so everything will be easier? And I'd like to give you an image of how that might look like. So let's start at the beginning. 20 years ago, Nix and NixOS didn't exist, and a dude called Elko Dolstra, he wrote his PhD thesis in the Netherlands at Universiteit Utrecht. And the idea was that he said it must be possible to build complex packages starting from nothing and have them successfully built with all their dependencies. Here in the background, you see, for example, the dependency graph of Mozilla Firefox. The details are not important, but I think it's obvious that it's very complicated because it has so many dependencies. And of course, you need to build all these things until you can finally have Firefox, for example. This is just like one example for some complicated package. The name Nix actually stands for nothing in Dutch, also in a German informal language. And the idea is to build complex software from nothing. And they did a very good job. Like, and meanwhile, in the last 20 years from that, they built the Nix package manager. This package manager is source and binary based. That means that if you want to install packages from the original recipes that they created and you don't change them, then you will get simply the binary package and it will be downloaded from the internet. But all the packages at any time can be completely customized. And as soon as you customize something, it will be able to build it from source, also transitively with all the dependencies. All the packages are described in the Nix script language. So it's not, Nix doesn't only mean package manager, but also its own language. It has garbage collection for packages. We will come to that later. And you can install packages just for yourself without root rights. But you can also install them for the whole system, of course, like with many other package managers too. But what's really interesting is it can start individual Nix shells. And in that individual Nix shell, you have like specific packages installed. And when you exit the shell, they're gone again. So you can have like very nice package management, which is like per session or for simply trying out packages without really installing them and so on. They also created NixOS. which is simply a GNU Linux distribution that is based on Nix. It has like nothing in common with other distributions. It's not a fork of any other distribution. They created it completely from scratch. And the interesting bits here are that you describe a NixOS system in one big configuration file. Of course, you can split it in sub-configurations, but the essence is that you describe the target state that you want to have your system in, and there are no steps on how to get there. There's no such thing as you have like with Ansible, where you just define steps on how to evolve an old system to a new one. You always simply describe the target, and the package management will find the way towards that configuration. You can also jump or skip between versions. You can roll back the version that you had installed before, and so on. We'll go into more details there later. Meanwhile, 20 years later, NixOS popped up as one of the top 10 open source projects on GitHub, measured by its contributors in 2022. They showed this slide on the GitHub Universe conference, and people were, most people didn't know about this project, and they were like surprised. What is this project next to Microsoft projects and so on? Interestingly, it also became the biggest package repository in the world. Here we can see the repology.org graph. Repology is a project that has nothing to do with Nix. They simply enumerate all the open source packages that are provided by all the distributions. And here on the graph, you see on the x-axis the number of packages that each distribution provides. On the y-axis, you see the freshness of the packages by some specific metric. And obviously, you want to be in the top right corner because those distributions have the most packages and the freshest packages. The question is, where is NixOS on that graph? In order to see that, you actually have to zoom out a little bit. And here we can see that Nix has more than double the number of packages. The only competition here is the Arc user repository, which is also very big. But as you can always also see, nothing is as fresh as the Nix packages package list. So this is impressive. I like to show these slides to people who are asking me like, okay, this looks all interesting, but is it mature? Is it big enough? Does it have my packages? The answers are yes, yes, and yes. Most likely you have been missing out packages by not using Nix packages. But okay, wait, lack of packages was never a problem in cloud IT. So let's get back to what it actually does and what it does differently. This is my outlook on the future. This is how I think how cloud IT providers, at least the ones who want to have a competitive advantage over the other cloud IT providers, will use NixOS like. I think there will be cloud providers who will simply build their bare metal servers with NixOS to provide their Kubernetes services. And they will have many advantages from that. But you can also, like not only on the infrastructure and backend side, you can build Docker images and your applications that run on top of this Kubernetes for your tenants. You can build those with Nix and NixOS too. Why would that be advantageous? So the core strengths of Nix and NixOS that you really need to know about are these. We have the extensive package library. You've seen it already that there's a lot. We get very reproducible builds and the packages are immutable. You get declarative system configuration. As I already said, you always describe the target of your system configuration that you would like to have. And you get atomic upgrades and rollbacks. The advantage for you is then that you have like less effort in maintaining your own variants of installer images and so on for bootstrapping your bare metal server fleet. You will get faster and more reliable updates with less risk involved. You will get perfect package isolation with and without containers. You get these, this notion of committing exact target configurations for your fleet. And you will have trivial resource cleanup. Most of these bullet points have been mentioned in other talks here in the ALASCA forum this year already. There have been tools which have been developed by other speakers because most distributions, package managers, and so on lack in these features. And looking at NixOS, it might have been possible that some tools would have like less need for existing if you build on top of NixOS. Let's get to the reproducible builds. When you build a package, may that be a compiled language binary as an application, or a Python package, or a library, or whatever, typically you define the inputs. Interestingly, these inputs don't have a base image. So you say, okay, I have the source code for my application, build system, compiler, and so on. I have configuration flags, environment variables. This is something that you list in some kind of an allow list. And in the sandbox that the build process will be put in by Nix, you have no internet access, and you only get exactly the paths mapped into that have been explicitly mentioned. As I said, without a base system, which makes this sandbox very, very minimal. And the likelihood that the same package outputs result in the output for consumption later, that these will be identical on two different systems which build the same package at different times is very high. It is actually that high that most of the packages are bit by bit identical in their output when you build them on different machines. So the output will be stored on the Nix store. This is a folder in the root file system under Nix store, and there all your packages reside. All these packages are, once they have been created, they are locked down to read-only, so you can't change them any longer. If you want to have a variant of this package, you would simply change one of the inputs, and then you will get a different hash in the name. So you can see here the package name contains actually a hash. And this hash is computed from the inputs. So if something changes, version of the source code, compiler upgrade, different environment variable, it's automatically a different package. This way you can have like many, many variants, like old packages and updates and whatever, on the same system, on the same disk, and they won't impede each other. So you can run updated applications. If they don't work, you simply restart the old ones. They are not lost. And if after your upgrade or your patching stuff is good, you can simply garbage collect the old ones away. What's very interesting is that this sandbox is very powerful. The same way it's kind of limited to only map the allow listed explicitly mentioned inputs. You can even run virtual machines in there for virtualization, for integration testing, which is done a lot on the NixOS ecosystem. You can also build Docker images there, and so on and so on. Another strength that comes from this is when you look at a package and its dependencies. Of course, when you build the package and you don't have the dependencies, then you need to build the dependencies first, and the dependencies too, and so on. And typically, for each of these blobs, Nix would ask binary cache servers if someone has built this package already. And if yes, then you don't need to build it. You could just download it. If no one has built it, then it would rebuild them. And then someone else could cache it from your machine. However, if you go through all the dependency chain and you go upwards, at some point, you of course arrive at source downloads. Every source download from a Git repository or an HTTP or FTP server or whatever is described along with its output hash. So people who describe package recipes, they always pin down what exactly the output hash of the downloaded packages needs to look like in order to be correct. So as soon as people have committed Nix packages somewhere, you can even download the contents for rebuilding from untrusted servers, because you can always check if the output is the right thing. So what's really nice here is you can take a grasp of a package, like let's take this root one here, and then Nix can automatically compute what do I need to download in order to build this thing. Then you can transfer it to an offline machine or whatever and rebuild everything there. And then, for example, give this as proof to your customers that these packages are built from exactly these source code versions, without any other modifications involved, so your software supply chain is safe. But you can also build the runtime closure. So what is needed on another machine to run this application? It will kind of give you the minimal set of packages that need to be transferred to a different machine in order to be able to run the application there. This is very nice because this way you can automatically compute those closures and transfer them where you want. So you can still use container solutions like Docker and so on for isolation of processes, but they don't become your primary, they're not your primary deployment mechanisms any longer. You can use containers if you want, but you don't need to in order to package and deploy your applications somewhere. Interestingly, each of these blobs here, they all build in their own little sandbox. So you have no big sandbox for all of them. Everyone gets their own minimal sandbox, which further improves caching. If you need some package that has been needed by some other package too, then you can get stuff from the cache because everyone used exactly the same closure. Sorry, not closure, sandbox. The next thing is when you want to build whole systems, a system image like an ISO live image or a Pixie boot image or anything is basically also a package. You can build that in the sandbox. And with legacy distributions, like looking away from NixOS for a moment, you typically, when some server boots for the first time in your fleet, and it gets an IP address for the first time, then you might have like Pixie booting, so that the server gets installed Ubuntu, Debian, or Fedora, or whatever you use. And as soon as that is installed, you would iron some Ansible actions over that server. And then after some minutes, it finally gets into the state that makes it a cluster machine that can be part of your cluster. In NixOS, you can actually skip some steps here. The description of the installer image, the stock one, you can always download the image from nixos.org, but you can also take the description that they took to build the image, modify it a lot, and then have your own image from the beginning. So you can actually Pixie boot machines into their final configuration without any other steps involved. If you still install that to disk or not is completely your decision. You can have it all, and it's very easy to actually build such modified system images. It only takes a few minutes, and because that runs in the Nix sandbox of the package manager, you don't really need to set up many things to have this going. You just need to install Nix and need to know how to modify system configurations. When you have a system running with NixOS already, let's say it runs in a specific system description. This might be the data structure that describes it as an example. And then you think, okay, we need to modify this server. We update a few packages, remove some services, we add some new services and so on. Then you can build this configuration on your administrator laptop. This is called like top level closure. And so this computes what packages need to be transferred to a system that shall run this new configuration. And after you computed that, you can copy it to the target system. So you would kind of via SSH, for example, the tooling does that automatically if you want, copy a few gigabytes of system there. And the old system is still running while that happens. As soon as the transfer is done, you can say, okay, let's switch to that new configuration. The top level closure of a system configuration comes with an activation script, and you can run that as root, and it will kind of substitute the running system against the new one. Of course, that does not automatically change the kernel, but the whole user land. If you want a new kernel, you can still run kexec or reboot the system. However, if the switch to the new system worked, but it does the wrong things now, you can simply activate the activation script from the old system and jump back. However, if that rolling back wasn't needed, you can stay at a new configuration and garbage collect the old one away. Such a switch from one system to the other takes 1 or 2 seconds typically. Interestingly, if the system goes dark after an update, or is simply not reachable via SSH, for example, you can reboot it and boot one of the old configurations. They are all reachable. You can decide how many old configurations are reachable and then improve the garbage collection characteristics. When you activate a system, you can actually activate that without changing the grub config. So if you don't trust in the new configuration, fear that it might go black or dark, you simply reboot the system and it boots the old system again, which is very nice. And then if the system ran for some time, you can actually update the grub configuration too. It's completely your choice. I've also found a very nice paper that actually describes in what way the NixOS system administration style is superior to other tools. The Traugot and Braun paper describes server fleet management styles. The first one is divergent. If you have like many admins who don't talk to each other and they don't use tools and then they do mistakes, over time, your server fleet reaches a state which might not be the one that you want. So these lines here go apart from each other where the actual server configurations are not the target configurations any longer. Of course, administrators are better than this today. So they use tools like Ansible, Terraform, and so on. And those tools give you better chances that your servers are actually in the state that you want them to be. But typically, for example, with Ansible, when an Ansible script runs, it describes the steps that should be taken on a system to evolve its state, but Ansible doesn't know in what state the system was before. You can have a few checks here and there, but it's never complete. With NixOS, you actually reach a congruent server fleet management style. So you describe the configuration that you want to be your server in, you zap the configuration over and boom, it runs just like this. And the tooling does the rest for you. I also painted like Helm and Terraform here somewhere in the middle because these tools already try to go into that direction very far. But I think the only server administration tooling that actually finished this evolution is the tooling from NixOS. What's also very nice is server management by side now. Developer environments. When you develop on repositories, you typically clone the repository at work, and then you open the README file, and the README file will explain what you need to do with your computer in order to have all the packages and configuration going so you can develop, build, and test your project. Sometimes this is very complicated, and if it's your first time at work and it doesn't work from the beginning, you ask yourself, is that your mistake or someone else's? And also updating tool chains is not very easy. It's typically very difficult. If you have, the more steps you have, even with Docker images and so on, sometimes it's hard to update that. With Nix it's different. If you just use Nix without NixOS for managing your development environment, you typically check out a project and you can run Nix develop. That will download toolchain files and so on. Depending on how much you need, it will take longer or not. And then you can start working. There's no steps. There's just this one step. I use this in many, many repositories, and I have seen many companies doing that. It works really great. What's also interesting is for every commit, you can have older and newer versions of your environment. So you can check out 5-year-old commits, and Nix Develop will work with the old tool chains from the old days too. Updating this is very easy. It's a single command. Nix typically employs log files like other package managers too. But of course, Nix maintains your Python packages, your Rust packages, your whatever packages all at the same time. So I reach my summary now. With Nix, you can get less customization effort, or you can have more customization with less effort. You will get faster and more reliable updates. You have perfect package isolation with or without containers. You can build much smaller systems. You are always describing your systems in their target configuration state declaratively. You're not thinking in steps how to get there any longer. The steps are kind of automatically calculated. You'll get trivial source cleanup because Nix has this notion of being able to calculate the closure of a system. And everything that is not referenced in the Nix store from any closure that is active can go to garbage. and you have very nice automatically working development environments. So the fastest way to learn how this works are, of course, the NixCademy trainings. I give these trainings under this label. I also do like general NixOS consulting, and I can also be the mentor that your employees can ask how to do things in order to avoid mistakes and so on. Thank you for your attention.
Thank you very much for the presentation, Jacek. Now we have some time for questions and answers. So if anybody from the audience has a question for the speaker, raise your hand or directly raise your voice, or just drop your questions to the meeting room chat. Okay, it does not seem to be the case. So thank you again, Jacek, for the great presentation. And so let's proceed with the outro slides. I will take over the screen share. I hope you are able to see my screen. Thank you. So, yeah, if you have some interesting topics and you want to share it at our ALASCA Tech-Talk, you can do it via email hello@alaska.cloud. If you are not sure whether your topic is in sync with this Tech-Talk, with the ALASCA Tech-Talk, please drop us an email as well, and we will support you. We will help you to figure out the scope and focus of your presentation. Any interest to share ideas is more than welcome. Next, some interesting news and events. The last ALASCA meeting took place at the end of April. A lot of topics have been discussed there, but mainly the governance model for the selection and then support of additional open source project. Next event, do not miss the opportunity to meet ALASCA at the Open Infra Summit, which will take place from the 13th to the 15th of June in Vancouver. There will be two ALASCA-related presentations. First, ALASCA and its mission, and the second one, ALASCA's first project called YAUK. Some additional presentation by some ALASCA members will take place as well. Question to audience, are there any news or events that anyone wants to share with us right now? Georg?
Even though it's not an event-related question, it's a late question regarding Jacek's input. Can you hear me, by the way? Yes. And the question is, you mentioned that with Nix Develop, it's like possible to basically use Nix stuff from many years ago. And my question is there like a guarantee that some kind of compatibility will be ensured so that my current Nix files can still be used in 10 years, because like interfaces and so on won't change. And yeah, because I think this would be pretty crucial for the long-term strategy. Because I also like Nix and wonder why is it not even more widely spread and more in use than it is. But yeah, do you have any information regarding that? Sorry for hijacking the other question opportunity.
Okay, of course, the so far in the history, it's like you can actually build 10 years old derivations and they build just fine. So the history has shown that they at least accidentally stayed compatible. But there's also awareness that this is one of the big killer features of Nix. So they will try hard to not break the tooling in a way that it doesn't execute or evaluate old Nix expressions any longer. There's no, I'm not aware of any tests that actually build 10-year-old Nix expressions on every change of the Nix tool or something. But there are many users of like old Nix expressions. So it hasn't been a problem yet, but I can imagine that as soon as someone realizes, oh, my old Nix expressions don't work any longer, that the community will take this very seriously and try to fix that. Although there are no working groups or special efforts to guarantee that, at least yet. And the reason why this is not adopted by more people is, I mean, Nix in general, I think it's the language. The language is completely different than other scripting languages. And people find that very alien. And I mean, when you look, for example, at a Docker file, it's very easy. You say, okay, there's a base image. I have like apt-get install this and that, and there you have your custom image. It's also very short when you do such things with Nix, but it looks completely different. I think that is the main reason.
Okay, thanks. Yeah, so as a user, it would be really nice to have this like explicitly guaranteed. But I'm also optimistic that if some kind of issue will arise on unstable, that this will be addressed so that stable remains stable also for old Nix files. Okay, thank you.
A comment on that maybe. Actually, the Nix packages, there are many packages out which do not build from source as in code, but they have expressions and download binaries from GitHub, an unpacked Debian pre-built binary, and transform that to NixOS. And obviously, if you download a 10-year-old thing where the original on GitHub is not, or on $ commercial unfree stuff, there's also that package style available. So you can't rebuild that at style of today.
That's correct.
And
oh, sorry.
Also it might be not comment now on that theme here for cloud industry, but actually, if you download binaries from somewhere and want to run them on NixOS because you have, let's say, no idea from HP, some weird server configuration tool or so, the libraries reside not in the paths you think they are, or it's not like in LSB style, because NixOS can have 10 versions of a libc at the same time, depending on the tool and so on. So they build, technically speaking, symlinks to those things, and you don't have /lib/libc, and you need some tooling, or if you want to run Steam games or so. So if you have something external that's not managed by the NixOS packaging system yet, you will have a strange experience in your admin life. until
yeah, that depends. I mean, it's good that you mentioned Steam. Steam, for example, is a package that you cannot get the source of it, of course. So if you download a 10-year-old Steam library, but that worked with the 10-year-old Nix packages dependencies around that, then if you still get that binary, then you will get it running with the old dependencies. That is a very nice example of how that would simply work with simply the download being still available. Steam is also very interesting because it checksums its own memory image. So NixOS binaries don't have like userlib something something. They don't. The search path doesn't even exist. So all the libraries are hard coded into the Nix store everywhere. And when you just download some binary from somewhere, you need to patch it because userlib folders where the loader would look for the libraries in doesn't exist. And you can't patch Steam like this because it would fail its anti-cheating hashing mechanism. So they actually put Steam into a namespace that simulates an old school FHS environment. And that happens in the normal Steam Nix package. So you can actually run games even with Proton support and so on your NixOS laptop without any problems because this mechanism works so well. I think Skype is also not available as a source download. So of course you need to download the binary. But then again, if you download an old binary and try to run it on a new system, you will have a bad time getting that to run, but it will be trivial if you get the old binary to run it on old NixOS expressions. On the NixCon in France last year in Paris, there was even one talk where the speaker has demonstrated how they even got to run an old Macromedia Flash-based tool running again on 10-year-old Nix expressions. They needed that for some weird reason for some customer. And the customer was amazed that they simply did it using Nix in a very reproducible way. That whole thing integrated as a VM into a more modern infrastructure.
And maybe you should also leave a word on what flakes are. So you don't have only the Nix configuration by itself, but you can extend your system like referencing directly to some GitHub stuff.
You can do that without flakes already. And I also didn't mention many other things. So I think more important than flakes are even the NixOS integration tests, which are very, very powerful, but we only had these 20 minutes. And I think to cloud IT, Nix would even be very useful with or without flakes. So I think it's an additional nice to have in some sense.
Thank you for interesting discussion. We slightly reshuffle our agenda, but it's okay. Any other questions to Jacek? If not, so let's proceed with the last slide. Last but not least, save the date for the next ALASCA Tech-Talk, which will take place as usual the last Thursday in June. So save the date 29th of June when Stefan Ilander from Stack IT will present us Gardener Kubernetes in production. So thank you for joining us today. Thank you especially to the speaker for presenting an interesting topic, and to the audience for the interesting questions. So thank you all. Stay tuned with the ALASCA community and see you next month.